Hi all, good morning. Last class we were discuss about this architecture of this 8254 IC. Okay. We know that the 8254 it is a programmable interval timer IC which is used to generate the timer or count or time delay in a process. Okay. So this is the architecture diagram of this 8254 IC. We know that it is having three counter units are there. Three separate independent counter unit is there. Counter 0, counter 1 and counter 2. Okay. All these counters can perform its operation independently. Okay. Then these counters are connected with the clock and a gate signal and an out signal. The gate signal is mainly used to disable or enable the counter, and the out signal is used to get the output. Okay. Then control word register is the read write logic is the, and also one data bus buffer is also there. Okay. Last class we have discussed about this. So, programmable interval timer, as I said that it is having three independent 16-bit counter. Okay, three independent 16-bit counter, and each of maximum counter rate is 10 megahertz. Okay, maximum count rate of this 8254 IC is 10 megahertz. And as I said that all these three counters, these are the counters, okay, all these three counters can independently control. Okay, it can independently programs. Okay, so these are the three counters. Okay, counter. Okay. Then here in this one data bus buffer is set. Okay, data bus buffer. Actually, it is a tri-state bidirectional 8-bit buffer. Okay, data bus buffer. Okay, it is a tri-state bidirectional. Bidirectional 8-bit. Bidirectional means both the direction it can send the data. Okay, so it is a tri-state bidirectional 8-bit data bus buffer. Okay, this buffer is mainly used to interface the our system with. Our system is this 8254 with the microprocessor. Okay, and this data bus is internal. This data bus is connected to the internal bus of this 8255 IC, and also these pins, that is D0 to D7 pins, these are connected to the system data bus. System data bus means our microprocessor data bus. Okay, and the direction of the data flow that will be decided from the control signals received from the microprocessor, that is read control signal or write control signal. Based on these two control signal, the data flow will happen, whether it is data from microprocessor to 8254 IC or from 8254 IC to microprocessor. All these data transfers are through this data bus buffer, and based on this control signal value, it will perform, whether it is an input operation or output operation. That is what I have written here. The direction of the data bus buffer is decided by the read and write control signal. Okay, so that's all about the data bus buffer. Data bus buffer, these are the points you need to remember. Actually, it is a tri-state buffer. Okay, it is a tri-state buffer, 8-bit data bus buffer used to interface the 8254 with the system data bus. Okay, and all the data transfer is through this buffer only. Okay, all the data transfer between the processor and 8254 IC is through this buffer only, and the direction of the data transfer is decided by the two pins, that is WR and RD bar pins in the control logic. That will decide whether it has to transfer the data from the processor to the 8254 IC or from 8254 to processor. Okay, so that is the data bus buffer. Then next one is read write logic. Okay, it is an important part in the 8254 IC. Sometimes for 3 marks and all, the question may comes. Read write logic of 8254 IC. Okay, so these are the pins. Okay, these are the pins. There are total 5 pins are there in read write logic. 5 pins you can see here. 5 pins are the RD bar, WR bar, A0, A1 and CS bar. Okay, so these are the 5 pins connected to this read write logic. RD bar, WR bar, A0, A1 and the CS bar. These are the 5 signal connected to the read write logic. Here, these RD bar and WR bar, we have discussed that. That will decide whether it is a write operation or read operation. Okay, that means whether the data is from processor to the 8254 or from the 8254 to the processor. Okay, so by using these two pins, it will decide that direction of the data flow. And A0 and A1. So these two pins, these are connected to the address pins of our microprocessor A0 and A1. Okay, so actually these two pins are used for selecting the particular counter. Okay, these two pins are used for selecting a particular counter. That means if A0 and A1, if both are 0, it will select a counter 0. Okay, and if it is 0, 1, then it will select counter 1. And if it is 1, 0, it will select counter 2. And if it is 1, 1, then it select the control word register. Okay, it select the control word register. So then one more pin is there, that is CS bar. Actually, it is a chip selector pin. Which is actually, it is an active low pin which is useful to enable the IC. Okay, if you apply a low signal to the CS bar pin, then only our IC will be in an active state. Then only all the operations will perform. Okay, so CS bar is an active low pin. We can call it as a chip select pin, which is used to enable the IC. Okay, and so these are the different operations based on the value of these pins. Okay, that means CS bar is equal to 0, then only all these operations will perform. Okay, that means our chip will be enabled only when CS bar is equal to 0, and these A0 and A1, it will decide whether it has to select a particular IC. Okay, sorry, particular counter 0, 1, 2, or whatever it is. Okay, then this WR and RD bar. Okay, so these are used for used to indicate whether it is a write operation or read operation. These two are active low pin, and whenever the value of these pins, that is, suppose if it is WR is 0, means it is a write operation, and if RD bar is 0, means it is a read operations. Okay, like it will perform its operations. Okay, so this is the read write control signals. Here in 8255, 5 control signals are there. 5 control signals are there: RD bar, WR bar, CS bar, and A0, A1. Okay, so RD bar read pin, WR write pin, CS chip selection, A0, A1 used for selecting the counters. Okay, then our control word register, as we have discussed, there control word register, for selecting control word register, we will use these two pins, A0 and A1 pin. Okay, for selecting control word. This is a control word register. Okay, so for selecting that control word register, if both value, that means A0 and A1, if both the pins are high, that means 1 1, then it will select the control word register. Okay, actually this control word register is used to the command word. Okay, used to write the command word. Actually, what it is specify that it is specify which counter it is used for performing the counting operation. And there are 6 mode of operations are also there in 825. 6 modes of operations are there in 825. Then this control word register that will specify which mode it is operating, and also it is specify whether it is a read operation or write operation. All these information will be available in this control word register. Okay, that is what I have written here. This register is accessed when line A0 and A1 are at the logic 1. Okay, when line A0 and A1 are at the logic 1. And also it is used to write a command word. Okay, write a command which specify the counter to be used, which counter we have to use, and its mode, which mode. There are 6 modes are there. Okay, and also either a read or write operation. All these information will be available in this control word register. Okay, so all the information related to these counter operations, modes, read and write operation, everything is within this control word register. Okay, then last one is our counter. Okay, 3 counters we are using here: counter 0, counter 1, and counter 2. Each counter consists of, I have discussed that, 16-bit down counter, which can be operated either in binary or PCD. Okay, it can count binary number and PCD numbers. Okay, either binary or BCD based on the values that is present in the control word register. It will operate a binary counter or BCD counter. Okay, and also its input and output is configured by the selection of mode stored in the control word register. Okay, and the programmer can read the content of any of these 3 counters without disturbing the actual count process. Okay, because all these counters are independently operating. Okay, and as we have discussed that each counter is having a 2 input signal, that is clock and gate, and an output signal. Okay, all these counters are having the same signal. One clock is there, gate is there, and out signal is there. Clock and gate are input signal, and out is an output signal. Clock is used to provide the clock, and gate is used to enable the counter, and out pin is used to select the output. Okay, take the output from the counter to the processor. Okay, so that's all about the counter. That is total 3 counters are there. All these counters are 16-bit counter. It can perform both binary or BCD. Both counting operation it can perform. Okay, all these 3 counters are independently operated. Okay, so that is counter. Okay, so that's all about the architecture. It is an important topic. ഇത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ആർക്കിടെക്ചർ നിങ്ങൾ നന്നായി പഠിച്ചോ, ആർക്കിടെക്ചറും അതിൻ്റെ എക്സ്പ്ലനേഷൻ. ഓക്കെ, ജസ്റ്റ് ഈ ബ്ലോക്കുകൾ ഓരോന്ന് നോക്കിയാൽ മതി. ഓക്കെ, അതിൽ റീഡ് റൈറ്റ് കൺട്രോൾ ലോജിക്കും ഇമ്പോർട്ടൻ്റ് ആണ്. 3 മാർക്കിനൊക്കെ ക്വസ്റ്റ്യൻ എക്സ്പെക്ട് ചെയ്യാം. So next, this is the pin diagram of this 8254 IC. Actually, it is a 24 pin IC. All these pins are arranged in a either side of the IC. So we can call it as a DIP, dual inline package. Okay, because pins are arranged either side of the IC. So 1 to 8. This is the data bus connection. Then clock 0, out 0, gate 0. And this is ground. Here 24th pin is VCC. Then read, write, CS bar. Okay, these are the control signals. A1, A0. Okay, so these are the control signal. A1, A0, A1, CS bar, DRD bar, WR bar. Okay, then clock, next clock 2, out 2, gate 2. This is for the counter 2, clock 1, gate 1, out 1. So this is for counter 1. Okay. ജസ്റ്റ് ഇത് ഓർത്ത് വെച്ചാൽ മതി. ഇത് ബൈഹാർട്ട് പഠിക്കണ്ട. ജസ്റ്റ് ഇങ്ങനെ ഒരു പിൻ ഉണ്ടെന്ന് ഓർത്ത് വെക്കുക. 24 പിന്നാണ് IC. രണ്ട് സൈഡിലായിട്ട് അറേഞ്ച് ചെയ്തിരിക്കുന്നത്. ഓക്കെ. Then this is the control word register format. Okay, control word format. Here, actually, this control word register is an 8-bit register. So D0 to D7 bits are there. Okay. Here in this control word register, these most significant 2 bits, D7 and D6. We will call it as SC1, SC0. Okay. Actually, these two bits are representing the different counters. Okay. Based on the value of these 2 bits, it will select a particular counter. Okay, D7 and D6. That is SC1, SC0. If both are 0, then it will select the counter 0. Okay. And if it is 0, 1, that is SC1 is 0 and SC0 is 1, then it will select the counter 1. And SC1 is 1 and SC0 is 0, then it will select the counter 2. Then if both are 1, then it is an illegal operation. Okay. So first 2 bits are used for selecting the counter in the control word register. Okay. First 2 bits are used for selecting the counter. The next 2 bits are the D5 and D4. You can see here D5 and D4. We will call it as RL1, RL0. Okay. So these 2 bits RL1 and RL0, that will decide the type of operation. That means read or load bit definitions. Okay. So RL1 and RL0, if both are 0, then latch counter for on the fly reading. 0, 1, read or load least significant byte only. 1, 0, read or load most significant byte only. 1, 1, read or load least significant first, then most significant. Like that it will work. Okay. Then next 2 bits are the D3 and D2. That is, and we will represent it as M2 and M1. Okay. These 2 bits are used for selecting different modes in the IC. Actually, we said that, we studied that there are 6 different modes are there in 8254 IC. 6 different modes are there. Mode 0, mode 1, mode 2, mode 3, mode 4 and mode 5. So 6 different modes are there. So for selecting a particular mode, so it will be based on the value of these 2 bits in the control word register. Okay, D3 and D2. That is M2 and M1. Okay, based on that value, it will select a particular mode for performing its operation. Okay. M2, M1 and M0. Three modes are there. Sorry. Okay. So 3 bits it will use. These 3 bits. M2, M1, M0. These 3 bits are used for selecting the 6 modes. Okay. 2 bits only we can select 4 modes. Okay. So 3 bits are used for selecting the 6 modes. M2, M1 and M0. Okay. So this is M2, M1, M0. If all the bits are 0, then it is select mode 0. Okay, then 0, 0, 1, it will select mode 1. Then If M2 is any bit, then if it is 1, 0, M1 is 1 and M0 is 0, then it will select mode 2. So this we will treat as a don't care. Okay, so here also it is don't care, M2 bit. Okay, then 1, 1, it will select mode 3. Okay, 1, 1, it will select mode 3. Then 1, 0, 0, it will select mode 4. 1, 0, 1. Then it will select mode 5. Okay, so based on the value of these 3 bits, M2, M1 and M0, it will select a particular mode for performing its operation. Okay, mode 0, mode 1, mode 2, mode 3, mode 4 and mode 5. Okay, the last bit is that is D0 bit. Actually, that to specify whether it is a hexadecimal count operation or binary BCD count operations. Okay, so this bit will specify. If BCD bit is 0, then it is a hexadecimal counter, and if BCD is 1, then it is a BCD count. Okay, so this is all about the control word register. ഇത് ജസ്റ്റ് ഇതിന്റെ ഓപ്പറേഷൻസ് ഒക്കെ ഒന്ന് ഓർത്ത് വെച്ചാൽ മതി, നിങ്ങളുടെ സിലബസിലും അങ്ങനെ പറയുന്നുള്ളൂ. ഓക്കെ, ജസ്റ്റ് എന്തൊക്കെയാണ് ഓപ്പറേഷൻസ് മാത്രം ജസ്റ്റ് ഒന്ന് ഓർത്ത് വെക്കുക. ഓക്കെ, 8 ബിറ്റ് ഉണ്ട്, then different operations. First 2 bit into operations, and then next 2 bit into operations, then next 3 bits used for selecting different modes, then last bit for for specifying the count operation, that is, whether it is a hexadecimal count or BCD count. Okay, so that is the control word register format corresponding to this 8254. ഓക്കെ, അപ്പോൾ ഇത് ജസ്റ്റ് നിങ്ങൾ ഈ ഒരു രീതിയിൽ പഠിച്ചാൽ മതി. കൂടുതൽ ഇതിനെക്കുറിച്ച് ഡീറ്റെയിൽ ആയിട്ട് നിങ്ങളുടെ സിലബസിലും മെൻഷൻ ചെയ്തിട്ടില്ല. സോ എന്താണ് കൺട്രോൾ വേർഡ് രജിസ്റ്റർ എന്ന് സ്പെസിഫൈ ചെയ്തിട്ടുണ്ട്, അതിൻ്റെ ഡിഫറെൻ്റ് ഓപ്പറേഷൻ മാത്രം ജസ്റ്റ് ഒന്ന് ഓർത്ത് വെക്കുക. ഓക്കെ, സംടൈംസ് 3 മാർക്സിന് ചോദിക്കുക, അല്ലെങ്കിൽ ഒരു എസ് എ ക്വസ്റ്റ്യൻ ഒക്കെ ഒരു 16 മാർക്കിൻ്റെ എസ് എ ക്വസ്റ്റ്യൻ ഒക്കെ ആണെങ്കിൽ നിങ്ങളെ 8254 എഴുതുന്ന സമയത്ത് വേണമെങ്കിൽ ഇതൊക്കെ ഇൻക്ലൂഡ് ചെയ്യാം. ഓക്കെ, ദെൻ അതിൻ്റെ എക്സ്പ്ലനേഷൻ ആണ് ഇവിടെ കൊടുത്തിരിക്കുന്നത്. സെയിം തന്നെയാണ് ഓരോ സെലക്ട് ചെയ്യുന്ന S1 S0 A0 A1 RL0 RL, സെയിം ഓപ്പറേഷൻ, അതിൻ്റെ എക്സ്പ്ലനേഷൻ ആണ് ഇവിടെ കൊടുത്തിരിക്കുന്നത്. ഓക്കെ, ദെൻ നെക്സ്റ്റ് we can discuss the different modes of operations in 8251. As I said that there are 6 different modes are there. Okay, so these are the 6 different modes in 8251. Okay, these are the 6 different modes. First one, mode 0. Mode 0 we will call it as interrupt on terminal count. Okay, mode 0 we will call it as interrupt on terminal counter. And the next one is mode 1, that we will call it as programmable monoshot. Okay, programmable monoshot. And mode 2 we will call it as rate generator or pulse generator. Okay, rate generator or pulse generator. And in mode 3 we will call it as square wave generator. Okay, we will call it as square wave generator. And in mode 4 it is a software triggered strobe mode. Software triggered strobe mode. Mode 5 we will call it as hardware triggered strobe. So these are the 6 different modes present in the 8255 8254 IC. Okay, mode 0 interrupt on terminal, mode 1 programmable monoshot, mode 2 pulse generator or rate generator, mode 3 square wave generator, mode 4 software triggered strobe, and mode 5 hardware triggered strobe. Okay, so we can discuss the different modes in detail. Okay, so before discussing the different modes, first we can see how the counting operation is performed. So for performing any counting operation, first we need to initialize the counter. Okay, then only it will perform its counting operation. Okay, so first we need to initialize. So to initialize the counter, for that, what are all the things we had to do to initialize a count? So for that, we need to, for initializing a count, it is a two-step process. We can say like that. Initializing counter is a two-step process. So for that, first we need to write the control word register. Okay, control, that means corresponding control word to control word register. Then only the control word register will get the information. Then only we can select which counter it has to perform that counting operation. So that is the first step. First, that we need to write the control word. Here one control word is register is the 8255 IC. One control word register is there. This is a control word register. So before performing the counting operation, we need to initialize the counter. So for initializing that counter, first we need to write the control word to the control word register. Okay. Then after writing the control word, you need to write the count value to the counter register. Okay. So you need to write the count value to the corresponding counter register. Okay. Then only it will start its operation. So that is the two steps for initializing the counter. First, you need to write the control word to the control word register. Then you need to write the count value. Okay. And we studied that a gate signal which is used to enable the counter. That means this gate signal is used to start the timer, start and stop the timer. Okay. So after counting a particular sequence, then you suppose if you need to stop that counter, then you can put a logic 0 to this gate signal. Okay, so this gate signal actually it is used to start or stop the counter. Okay, then one more line is there, output line. So from that output line, you can take the output. After the counting operation, you can take the output. Okay, and so that is how we will initialize the counter. Okay, that means first you need to load the control word to the control word register. Then you need to load the count value. Okay, then only it will start. After that, you can start the counter by enabling the gate signal. Okay, then it will start decrementing the counter from the count value to 0. Okay, when it reaches to 0, then it will perform corresponding operations. Okay, so that is our count operations. Here in mode, in this different mode, you can see mode, these modes, mode 0, mode 0, and mode 2, uh, mode, mode 2, and mode 3, mode 4. Okay, 1, 2, 3, 4. So mode 0, 2, 3, 4. Okay, it is having some specific feature. That is, once you load the count value to the counter register, and if you give the enable signal, that means gate signal high, then the counter will start decrementing its count value automatically in these three counters: mode 0, mode 2, mode 3, and mode 4. That means uh, once you load the count value to the counter register and give the enable signal. Enable signal means our gate signal. Okay, if the gate signal is high, then automatically the counter will start decrementing its count value. But it will start its automatically, it will start its operation, decrementing from the count value to 0. Okay, but in mode 1 and 5, in mode 1 and 5, here actually this mode 1 and 5, that is mode 1 and 5. Actually, here the gate signal, it acts as a trigger pulse. Okay, trigger pulse means first, suppose first you load the count value, then it will start decrementing, but only when the rising edge of the gate signal is occurring. then only it will start decrementing the counter value. Okay, only when here this is the clock pulse. Okay, here clock pulse is like this. Okay, then in mode 1 and 5, it will start decrementing only when the gate signal rising edge occur. Okay, then only it will start decrementing its count value. Okay, so that is mode 5 and mode 1. So these are the different modes. Mode 0, mode 2, mode 3, mode 4. These modes are, it will automatically start decrementing when the gate input is high. Okay, but in mode 1 and 2, it will start its decrement only when the rising edge of the gate signal. Then only it will start decrementing its operations. Okay, so that's all about the different modes. Now we can discuss in detail mode 0, mode 1. So അത് നമുക്ക് അടുത്ത ക്ലാസ്സിൽ നോക്കാം, അതിൻ്റെ ഡീറ്റെയിൽഡ് ആയിട്ടുള്ള കാര്യങ്ങൾ. ഓക്കെ, അപ്പോൾ ഇത്രയും ഓർത്ത് വെക്കുക. ഡിഫറെൻറ്റ് മോഡ്സ് ഉണ്ട്, 0, 1, 2, 3 ആൻഡ് 3, 4 ആൻഡ് 5. ഓക്കെ, അതിൻ്റെ ഓരോന്നിൻ്റെയും പ്രത്യേകതകൾ ഓർത്ത് വെക്കാം. നമുക്ക് ബാക്കി അടുത്ത ക്ലാസ്സിൽ ഡീറ്റെയിൽഡ് ആയിട്ട് അതിൻ്റെ മോഡ്സിൻ്റെ ഓപ്പറേഷൻസ് പഠിക്കാം. ഓക്കെ, നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ആശിഷ്, അഭിനവ്, അഭിഷേക്, ആദിത്യ, ഐശ്വര്യ, അഖിൽ സി വി, അമൽ, അഖിൽ കെ, അമൽ, ആമിന, അനൈന, അനിരുദ്ധ്, അൻഷിത, അനൂജ, അനുപമ, ആരോമൽ, അർപ്പിത്, അരുൺദത്ത്, അശ്വിൻ കെ, ഫസ്ന, റംഷാദ, ഋതുർ, ജെറീഷ്, ഖദീജ, ലിഖിത്, ലിയാന, മിഥുൻ, നാസിഫ്, റാസി, മിനാജ്, നിഹാൽ, സാലിഹ്, ഷഫീഖ്, നബീൽ, നന്ദിത, നന്ദ, നന്ദിത. ഓക്കെ. നിവേദ്യ. പ്രിൻസ്. നൂഹ. ഋഷികേശ്. ക്രിസ്ത്യൻ. ഋത്തിക്. രോഹിത്. സഫീൽ. സങ്കീർത്തന. സാരംഗ്. സേജൽ. ഷബിൻ. സെവിൻ. ചിഷാജ്. തനുശ്രീ. തേജ. തുളസി. വൈഷ്ണവി. വിഷ്ണു. വൈഷ്ണ. യാദവ്. അമൽ. ഓക്കെ, നമുക്ക് അടുത്ത ക്ലാസ്. താങ്ക് യു.